But we don't have to stay in quadrant 1. We can make non-acute angles, so obtuse or over 180 degree angles, and we need to still be able to take the trig functions of all of those. This is going to sound familiar, like what we did at the end of chapter 1, but it is now in a coordinate grid system. So to do this, we're going to use what's called a reference angle. A reference angle is an angle that we're going to use to refer back to something in quadrant 1 that we do know. A value that we are aware of, a value that we know off the top of our head, a value from the hand trick. We're going to use that reference angle and then all start trig class to be able to tell the different measurements. So if we review for a second, around a quadrant, all of the functions are positive in quadrant 1. Sine and its reciprocal are positive in quadrant 2. Tangent and its reciprocal are positive in quadrant 3. And cosine and its reciprocal are positive in quadrant 4. So that's a huge help. We're going to know whether the trig function will be positive or negative if we know what quadrant it's in. We can also take this reference angle, which we're going to write as theta prime. So we're going to put a little tick mark next to theta to talk about the reference angle. Now your reference angle is going to always be directly down or up to the x-axis, not the y-axis, the x-axis. So in quadrant 1, your reference angle and your regular angle are exactly the same. They will be the same section going straight down to the x-axis. In quadrant 2, the reference angle is going to be straight down to the x-axis. So it finishes off the 180 degrees to make a flat line. In quadrant 3, your flat line is going to go back to 180 degrees. So it's going to go straight up to the x-axis. And in quadrant 4, it's going to be what finishes a full revolution or what makes us get to 360. That is your reference angle. Now each of these have little bitty formulas up here. If you look in quadrant 1, it says that your reference angle is the same as your angle. In quadrant 2, it says your reference angle is 180 degrees minus your actual angle, what finishes 180 degrees. In quadrant 3, it's your angle minus 180. How much further you went past 180 is another way to think about it. And in quadrant 4, it's what it would take to finish 360 or 360 minus your angle theta. That'll help us find that reference angle and be able to do trig more easily. So let's just make sure we understand the concept of reference angles. In number 1, part A, we're going to sketch the angle so that we know what quadrant it's in, and then we're going to find the reference angle for each of the angles. So if we were to graph 218 degrees, first we have to know what quadrant it belongs in. If we do our degree measurements around the quadrants, we have 0, we have 90, we have 180, we have 270. Which quadrant does 218 belong in? The third. It doesn't have to be accurate, but give me an angle all the way around to the third quadrant. That's going to be 218 degrees. That's theta. Theta prime is going to be here. I want to know how much has happened from 180 to make it to my angle. So if I have that theta is 218 degrees, theta prime is just going to be 218 minus 180 degrees, taking away that full top semicircle, which means that theta prime is 38 degrees. Am I always going to what?
Go to 180?
Yes. Quadrant 3 will always subtract 180 from that angle. Because basically we're saying that we took 180 degrees to get here and 38 degrees more to get all the way down to 218 degrees. So we took care of the 180. This little piece right here is 38 degrees.
And you subtract 180 because it's the closest like, x.
Quadrant, yeah, it's closest x value, yes. I guess I can make that purple. That would be nice. So we know we're finding that purple value. Okay. Now let's do a crazy one. Let's find the reference angle for 1,387 degrees. Okay. For this one, I'm just going to list out, because yes, the quadrants all stay the same. I'm going to list out revolutions or complete circles. This would be 0, then 360, then 720, then 1080, and then if I go a little bit further, one more revolution would be 1,440. So that is 1, 2, 3, 4 different circles around the whole thing. Okay, if I do one full rotation, that's 360 degrees. If I keep going, 720. If I keep going, 1080. I still need to keep going. I'm going to actually make it all the way back into quadrant 4 before I stop and make my angle. That is 1,387 degrees, or at least it's the quadrant that it's in. Since it's in quadrant 4, my formula says 360 degrees minus theta. Well, obviously, 360 isn't big enough, but 1440 is big enough. So I'm actually going to use this multiple of 360 to subtract my value so that I can figure out the reference angle. My reference angle for this guy is just asking how much is left between the final terminal side and the next time I would finish an entire revolution. So theta is 1387, which means that I can find theta prime by doing the next complete revolution, which is 1440 degrees, minus theta, 1387. Bloop, 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 that's a calculator question. We'd get that our reference angle, theta prime, is 53 degrees. Now again, in the formula that's in my chart, it just says for quadrant 4 to do 360 minus theta. Why did I choose to do 1440 minus theta?
Because that's how many revolutions you're in.
Yeah, we had to keep going. So I don't want to stop at 360 because I had to keep going 3 times. To finish out the 4th circle around here, it would take 1,440 degrees. So I'm using this multiple of 360 to subtract my theta instead of just 360 minus theta.
Well, you did that number because it's closest to 1,387.
Yes. Yeah. If you had stopped here, you'd have a number bigger than 360 as your reference angle, and you know you don't want that. You want an acute angle, a small angle. Any other questions? So finding these reference angles is important because it allows us to do trig for values that are outside of quadrant 1 without having to draw a unit circle. So in example 2 on the back, we're going to find the 6 trig functions for the values of them for the angle measurement of 210. Now it's already drawn for you. We have the angle 210, and they also found that my reference angle is 30 degrees. How did they get that 30 degrees again? Yeah, so if theta was 210, they said theta prime can be found by doing the 210 degrees minus 180. So they got that my reference angle is 30 degrees. Oh, snap, I know all of the values for 30 degrees because it's on my hand trick. It's one of the values I had you memorize. Now, the only thing I need to do before we start doing this is we need to recognize what quadrant we're in. 210 degrees is in quadrant 3. Which trig functions are positive in quadrant 3? Tangent and its reciprocal. So when we list out all 6 trig functions for 30 degrees, I need to make sure that I'm actually doing it not for 30 degrees, but for 210. So I could say the following. I would say that the sine of 210 degrees, which would be like doing the sine of 30. Sine of 30 is 1/2. But in quadrant 3, sine is going to be negative. So you just pop a little negative on there. The cosine of 210, I'm actually thinking about the cosine of 30. The cosine of 30 is square root 3 over 2. But since I'm in quadrant 3, I'm in quadrant 3, cosine is going to be negative. If I do the tangent of 210 degrees, I'm like in my head doing tangent of 30. I've memorized that to be square root 3 over 3. Tangent gets to stay positive though because we're in the third quadrant. That's 3. I need the rest of the 6, but they follow the work we just did. So sine's reciprocal is cosecant. So the cosecant of 210 degrees is just going to be the flipped over version of negative 1/2, which is negative 2. Secant of 210 is just the flipped over version of cosine of 210, which if I just flip it over would be 2 over square root 3. Ew, you know I don't want that square root in the bottom. So we would rationalize the denominator. This would be negative 2 square root 3 over 3. Last but not least, cotangent of 210 degrees is just the reciprocal of tangent of 210 degrees, which would be 3 over root 3, but again, don't want that radical in the bottom, so I rationalize the denominator. Oh, these 3's cancel. This one would just end up being square root 3. So there is all 6 values. We do a quick check for ourselves. Did we make sure that only tangent and its reciprocal are positive? Are the rest of them negative? Yes, so we're good. Negative, negative, positive, negative, negative, positive. So you think in terms of the right acute angles of 30, but is actually able to do a value outside of quadrant 1. So some steps here are listed. They're exactly really what we did. We got to skip step 1 because our theta was between 0 and 360. But if it's outside of 1 revolution, you just find the coterminal angle and you can find the reference angle. So basically, I really want you to focus starting on step 2. To find the trig function for any values, you're going to make sure you know that reference angle. Once you know the reference angle, you can find the trig values for that reference angle. And then just make sure you give it the correct sign based on what quadrant it's in. So for example, we're just going to find cosine of negative 240. Well, negative 240, if we find a coterminal angle, which means I want the same ending place, we're just going to add 360 to negative 240. This means that we're actually finding the cosine of 120, because negative 240 plus 360, so that I get a positive angle within 0 and 360 means cosine of 120. If I graph 120, 120 degrees looks something like this. It'd be the same as graphing negative 240. I just chose to go this direction. My reference angle is going to be this guy right here. How big is my reference angle? 60. How did you find out 60? Yeah, 180 minus 120 is 60 degrees. So I'm actually doing the trig for 60 degrees. So instead of asking you the cosine of negative 240, I can really ask you, what is the cosine of 60 degrees? That should be something we know off our hand trick. 60 degrees is my index finger coming down. What's the cosine of 60 degrees? 1/2. But we are in quadrant 2. So the cosine of negative 240 is going to be negative 1/2. Because in quadrant 2, cosine would be negative. So you think in terms of the quadrant 1, you just pop the correct sign on it depending on what quadrant you're in. And color code this a little bit differently so you can see what I'm doing. There we go. Okay, let's try the next one. I want you to find the tangent of 675. What should I do first? Subtract, because we want to get it between 0 and 360. So 675 minus 360, what do you get? 315 degrees. Okay, so that makes me coterminal, so we're at the same angle. It's just easier to work within one revolution instead of multiple revolutions so that you don't have a graph that spirals like we did on the first page. If we graph 315 degrees, what quadrant am I in? 4. So it's going to look something like this. Which means my reference angle is going to be here in the gap that's missing. How much is my reference angle? 45 degrees. Because it would take 45 more degrees to finish that circle, so theta is 45 degrees.
What happens if it gives us what happens if the reference angle is 40?
It won't be. If the reference angle is 40, it's a calculator question. We only do the ones by hand that are the special right triangle numbers. So 30, 60, 90, 45, and 0. That's a great question. So if it's a non-calculator section, you do get a number that's not one of the ones we know on the hand trick, something wrong happened. Go back and try it again. I would give you a calculator for that question. So here, we know that the tangent of 45 degrees is what? Square root of 2 over square root of 2, which is 1. But we are in quadrant 4. In quadrant 4, should tangent be positive or negative? Negative. So really, that means that the tangent of 315 degrees will just be negative 1.
What if we do 675?
It would be the same. So if you had a calculator and you did this, and you put tangent of 675, tangent of 315, you would get the same number, because they're coterminal. They end at the same place.
What about on my math class?
It's going to be asking you for these values. For these values here.
Okay.
So it doesn't matter what angle you use as long as it is a coterminal angle. If it says something about that, it will tell you what kind of coterminal angle to write. All right, last but not least, let's take these special angle values and let's apply them to things. I want you to evaluate cosine of 120 degrees plus 2 times sine of 60 degrees squared minus tangent of 30 squared. Ooh, that's a lot. But we can do it entirely by hand. The only one that's going to require the use of a reference angle is this term right here. I know the value of sine of 60. I know the value of tangent of 30, so I won't need to use a reference angle for those values. But cosine of 120 does require a little bit of work. For cosine of 120, that means that my theta prime, my reference angle, is going to be 60 degrees. How did I get that without drawing a picture?
180 minus 120.
Yes. 180 minus 120 is 60. I know I need to finish a 180 or finish a 360, so I know it takes 60 more degrees. So I can really just do the cosine of 60 degrees. What is the cosine of 60 degrees? 1/2. Okay, but I'm in quadrant 2. So what is the cosine of 120 degrees? Negative 1/2. Because of all-star trig class. Okay, so if we do this, we know that cosine of 120 is negative 1 over 2. And then I'm going to add 2 times the sine of 60 degrees squared. What is the sine of 60 degrees? Yeah, radical 3 over 2. That's something we know straight up from our hand trick. And then I'm going to subtract tangent of 30 squared. What is the tangent of 30? Square root 3 over 3. Notice that yes, when I write the squared with the words tangent or sine, the little square goes here behind the word. But when I'm writing the value, the squared goes behind the value. Do y'all see the difference there? saying the same thing. Basically, it just keeps us from being confused. If I wrote sine of 60 squared, that looks like I'm doing the sine of 3,600 because I would accidentally square the 60 instead of squaring the sine. So it's a shorthand to allow us not to have to use double sets of parentheses. So we put the square next to the words. Yes? Great question. Okay, well this is all numbers. Let's do some algebra. We can't reduce the negative 1/2 yet, so we'll leave it like that. If we take square root of 3 squared, that's just going to be 3. So this is going to be 2 times 3 over 4, because you square the top, square the bottom. Square the top, square the bottom for the blue, that's going to be 3 over 9. We'll just flex our ability to do some general fractions here. Top times top, bottom times bottom here, so this is going to be negative 1/2 plus 6 over 4 minus, and I'm going to reduce this fraction to 1/3. Obviously, you could turn to a calculator at any point, but we're going to do this in our heads. So, we need to have a common denominator. What's the easiest common denominator to change all of these fractions to? 12. So, if I take negative 1/2 and I make it out of 12, that's negative 6 out of 12, because 6 is half of 12. 4 times 3 is 12, so 6 times 3 is 18. 3 times 4 is 12, so 1 times 4 is 4. Negative 6 plus 18 minus 4 is 8 over 12. And again, flexing our math muscles. What are both 8 and 12 divisible by? 4. 8 divided by 4 is 2. 12 divided by 4 is 3. 2/3. Look at that. We didn't have to use a calculator at all, and we did a really complicated trig value. Last few bits for today. We're going to evaluate each function by first expressing it in terms of a function of an angle between 0 and 360. Again, the idea of using a coterminal angle so that it's within one revolution keeps me from having to draw pictures that are like spirals. It makes it a little bit easier to visualize. So instead of evaluating the cosine of 780 degrees, what is a coterminal angle I can use instead? Meaning, we're going to try to get this number smaller. Let's subtract 360. What do you get? 420. Still not small enough, so let's do it again. Subtract 360 one more time. 60. What is the cosine of 60 degrees? 1/2. I don't have to change this to positive or negative because it's coterminal with a quadrant 1 angle. This is already my reference angle. So I don't have to do any extra work with reference angles because 60 is already in quadrant 1. And it's coterminal with the angle I started with. So what I'm saying is, let's look at the next example to see the difference.
Wait, why did you have to do it twice?
The first time I subtracted 360, it was still too big because this number is still bigger than 360. I want the number that I'm doing the trig for to be between 0 and 360. So it's just one circle instead of multiple. In part B, if I do what I just did, I want this number to be between 0 and 360. So again, I'm going to add 360 this time. When I add 360, I would get that this is the cotangent of negative 45 degrees. Still not between 0 and 360, so we do it again. Plus 360 again, I would get that I'm finding the cotangent of 315. This time, when I have a positive angle between 0 and 360, is it in quadrant 1, like the part A was? No, part A, 60 degrees is in quadrant 1, so that's easy. 315 degrees, what quadrant is that in? That's in quadrant 4, so I have a little bit more work to do here. I have to use a reference angle. If my angle is 315, yeah, it would look like this. I think we've already done this one. That means that my reference angle here, theta prime, would be 45 degrees. So what is the cotangent of 45 degrees? Well, what cotangent is the reciprocal of which one? Tangent. So let's back up. What's tangent of 45?
Oh, the square root of 2.
Over square root of 2, which is 1. The reciprocal of 1 is 1. But then in quadrant 4, which is where I'm doing this function, the cotangent of 315 degrees is not going to just be 1. It's going to be what? Negative 1. So we look for an angle between 0 and 360. That's the step 1 in that main idea section. We keep adding or subtracting 360 until we get an angle between 0 and 360. We then either straight up solve it if it's in quadrant 1 or use the reference angle to solve it and make sure we use the correct sign. All right, last question for today. It says, let's find all the values of theta if theta is in the interval from 0 to 360 and cosine of theta is equal to negative square root 2 over 2. Now this part right here is just telling me that we are only doing one revolution. We should not answer with a theta that is smaller than 0 or bigger than 360. This section right here is trying to give me a hint about what quadrants I'm working with. If we think about all-star trig class, that's way too big. Which two quadrants is cosine going to be negative? Sine and tangent. So I have two options for where this could be because I know that cosine is negative. Okay, so we're going to have two answers because we have two quadrants where it could possibly be. The next thing I need to know is what angle I'm even looking at here. So if the cosine of theta is equal to negative square root 2 over 2, what is theta? 45, because isn't the cosine of 45 the square root 2's over 2's? So theta is some multiple of 45 degrees. I specifically want the multiples that use the reference angle of 45 degrees in quadrants 2 and 3. So in quadrant 2, if my reference angle is 45 degrees, then what is my big angle? So what I mean by that is, if in quadrant 2, we know that this is 45, what is this? 135. So there's one answer. Let's do the same thing for quadrant 3, the other possible quadrant. So in quadrant 3, if my reference angle is 45, then what is my possible angle? 225. We got 225 by looking at this and saying, okay, if we're in quadrant 3, should be here, if my reference angle is 45 degrees, I want all of this. So 180 plus 45 is 225. So those are the possible values of theta if cosine of theta is negative square root 2 over 2. It's one of the 45-degree reference angles in quadrant 2 or 3, which is where cosine is negative. Comments, concerns, questions before we call it an end for today?
So it's both of those answers.
Yes. This would be a multiple answer kind of question. It would be like, put commas in between your answers. Now, if it gives you more information to where you could narrow it down to one, like how we did the other day, whereas I asked you which quadrant is it in, you'd only have one answer. But this one, there's two possibilities, because I just know that cosine is negative.